First of all, if you want to remember something about a chemical, we have to know the applications of that first. So that we can remember we will try to remember the applications of KM104. See these pictures. These are all caused due to fungal infections. This one. So this is often seen in some people. This is due to fungal, and this is also due to fungal infection. And this is a kind of skin disease called dermatitis. Dermatitis. So the KM104 is used as a cure for this. First of all, we know that it is used as disinfectant. Disinfectant. And it is used for fungal food diseases. This one and this one are fungal food diseases. Fungal food diseases. And it is used in the treatment of dermatitis, and it is used in the treatment of dermatitis. And thirdly, it is used in the treatment of softening water. Softening water. So we'll call it as regeneration chemical. Regeneration chemical. KM104 is a regeneration chemical in well water treatment. To treat the well water. Well water, we know that usually hard water. So that in treatment of hard water, KM104 is employed. So these are the applications we can easily remember. This is used as disinfectant, and it is used for fungal food disease. It is used in the dermatitis, and it is used as a softening agent or regeneration chemical in the well water treatment. Right. Next, we can go for some interesting fact regarding the KM104. Interesting fact in the sense, what we can say, that the KM104 is purple colored. The KM104 is purple colored. Let's go for the electronic configuration of manganese. Manganese is in +7 oxidation state in KM104, as we all know. So the electronic configuration for manganese is argon 3d5 4s2. Then it will be in +7 oxidation state. It has only argon. Argon means completely filled. That is no unpaired electrons. No unpaired electrons. No unpaired electrons in the sense, then how the color will be. So colored even though it does not have unpaired electron. So no unpaired electron. Then how it will be colored. For this, we have to know a small thing about charge transfer. Small thing about charge transfer spectra. Charge transfer spectra. That is, in coordination complexes, as I told you earlier, there will be a central metal atom, and the ligands will donate its pair of electrons to form the complexes. So these are called ligands. The central metal atom will accept a pair of electrons from the ligands. Right. So what happens at this time? The ligands are transferring its electron to the metal, thereby transferring the charge. Right. That we call as ligand to metal energy transfer. LMCT, ligand to metal charge transfer. There are three types of charge transfer here. That is, when the ligand gives electron, it is called a ligand to metal charge transfer. That is LMCT, ligand to metal energy transfer or charge transfer. Next, when the charge is transferred from metal to ligand, it is called MLCT, metal ligand charge transfer. And from one oxidation state of metal to another oxidation state of metal. So this is called MMCT, metal metal charge transfer. Metal metal charge transfer. Like that, if ligand, the charge is transferred from one ligand to another ligand, that is called LLCT, ligand ligand charge transfer. These are the four types of charge transfer. That is LMCT, MLCT, MMCT, and LLCT. Right. Here in the K-monopore, this is a process. That is, LMCT is responsible for the color in the K-monopore. Got it? And this charge transfer spectra is due to the redox transition. I already told you, na, the metal accepts the electron from the ligand. So these are all ligands. The metal accepts the electron from the ligand. So what happens here? Reduction takes place. Gain of electron, reduction. What happens to the ligand here? Loss of electron. Oxidation takes place. So put together, we can call it as a redox reaction. Right. So these are all redox transitions. And these transitions mostly occur in the UV region. And these are all observed in all complexes, all coordination compounds. Complexes in the sense coordination compounds here. In all complexes. Ligand to metal charge transfer. So let us have a look over these things. Transfer of an electron from a ligand to ligand orbital to vacant metal orbital. Right? Actually, there should be placed. So the metal is there. The metal orbital should have vacant orbital. Then only the ligand can place its electron over there. Right? So what are the need for the LMCD transition? There should be a metal with a vacant orbital. There should be a metal with a vacant orbital, and there should be a ligand with the pi electrons. There should be a ligand with the pi electrons. So the pi donor ligand shows LMCD transition. So what type of ligands will undergo LMCD? Halides, oxides, sulfides, and selenides. Halides, oxides, sulfide and selenide. These type of ligands can undergo LMCT transition. These type of ligands can undergo LMCT transition. Next, some other conditions. Condition in the sense for the LMCT to take place. Metal should have high energy vacant orbital. The metal should have high energy vacant orbital and it should be in the highest oxidation state. This is in the case of metals. I told you that it should have vacant orbital. The energy of the vacant orbital should be high and it should be in the higher oxidation state. Higher oxidation state means it should have more space to get the electrons. And the ligand should have, in the case of ligand, it should have low energy filled orbitals. And as I told you, reduction oxidation, internal oxidation of ligands. Oxidation the ligands means oxidation is loss. Oxidation is loss. OIL, oil. Oxidation is loss. And reduction. Reduction means RIG. RIG. Reduction is gain of electrons. So metals gains electrons. So reductions. Ligand loses electrons. So oxidation here. The metals may be in main group, transition or inner transition. So wherever the metal may be, the LMCD transition can take place. So these are the conditions for LMCD transition. That is ligand metal charge transfer. Right. Ligand metal charge. This is the reason. Now, these are all for the reason why K monophore is colored. Why K monophore is colored? What is the reason? LMCT. Ligand metal charge transfer is the reason for the color of the K monophore. Got it?